1869, the Russian chemist Dmitry Mendeleev recognized that if elements were arranged in order according to their atomic weight, relative atomic mass, a definite pattern could be seen in the properties of the elements. This led ultimately, after some refinement of the theory, to the development of the most important tool available to chemists, the periodic table of elements, which lies at the core of chemistry.
Electronegativity is the ability of an atom in a molecule to attract shared electrons. The electronegativity of an atom increases up a period and increases across a group. Atomic size increases down a period. The atomic radius of a chemical element is a measure of the size of its atoms. Ionization energy is the quantity of energy that an isolated gaseous atom in the ground electronic state must absorb to discharge an electron. Group 1 is the alkali metals. These elements are highly reactive at standard temperature and pressure. These elements also occur in nature. The alkali metals display well-characterized homologous behavior.
Yeah, you're terrible. Stop it. You just go ahead.
Alkaline metals from group 2 all occur in nature. They are shiny, silvery white, somewhat reactive metals at standard temperature and pressure. The transition metals make up groups 3 through 12. These serve as a bridge or a transition between the two sides of the periodic table. The halogens located in group 17 consist of 5 elements. The name halogen means salt producing. When halogens react with metals, they produce a wide range of salts. Noble gases make up group 18. In standard conditions are odorless, colorless, monatomic gases with very low chemical reactivity. They are typically unreactive except under extreme conditions.
Juke chains! Big matter, I cannot lie. You other chemists can't deny. When the mass and volume are combined, then I get this tingling in my spine that shouts chemistry word. Now let's start this chemical reaction. I'll get the reagent and we'll cut to the reaction. Period across the family down. The periodic table is the greatest in town. Helium is number 2. A noble gas is unsurpassed. In aeronautics, far and wide, boric acid, pesticide. Carbon is really widespread. Charcoal, diamond, pencil, lead. Anything alive or dead, carbon bonds, the most it's said. Nitrogens and cyanide, in rocket fuel it is applied. Fluorine chilling in the fridge, the most electronegative. Neon lights on Vegas nights, sodium in tasty bites. Iron is a metal, you see every day. Oxygen eventually will make it rust away. Carbon ordinarily is cool, crush it together and you get a joule. A substance is an element or compound, an element which you get when no more can be found. A compound has fixed proportions, and they're both all pure with limited distortion. Team up to make a compound when elements are combined.
Ready?
Team up to make compounds when elements combine, or make up one element when it's atoms at the same time. If I was in an atom, I would be really small, really microscopic, and that's totally not all. Get a lot of me together and it matters what I would form. I'd have mass, volume, and density. Yeah, that would be the norm. My table is periodic, and just in case you forgot it. Atomic is the kind of weight in which my electrons rotate. A noble fate when you see all 8. Balloons are full of helium, and so is every star. Stars are mostly hydrogen, which may someday fill your car. Platinum and gold are pretty pricey. Mercury thermometers will tell you when it's icy. Francium will last a little time. radiums, and actinides at 89. From here on, the list gets kind of boring, so I'll just do the highlights because I don't want any snoring. Mendeleev discovered elements that existed to fill the gaps like he predicted. One final element is probably worth a mention, that is mendelevium. The table is his invention. If you open your eyes wide and take a good look, you'll find more chemistry than you'll see in a book. If you take the time to understand, you can grasp the ideas in the palm of your hand. Word.